All right, so here I'm very quickly going to go over each of these questions. I just want to highlight what perimeter is. It is the distance around any shape. It doesn't matter what shape. We don't actually need a formula for it. We're really just adding up all the sides going around the outside. Sometimes we have nice, easy formulas to follow. Sometimes we don't. This kind of a shape, we would just have to figure out what each of those are and put all of those together. Some shapes are really regular, like this. This is just a rectangle where we have an equation. The perimeter of a rectangle is 2L plus 2W. So that means 2 times the length and 2 times the width. Honestly, to me, this is overcomplicating it. The perimeter of anything is just adding up the sides. If this is a rectangle, I know that this and this are the same. I know that this and this are the same. So really, I would just add up all of these sides. You can also plug them in there. 2 times, let's call this the length, so 2 times 5, plus 2 times the width, I'm going to call that 2 here. So it'd be 2 times 5, that would be 10. 2 times 2, and that's 4. So the perimeter of this is 14 centimeters. Or, again, you could really just add up these 4 numbers and get the exact same thing. I want to point out that the units here are just centimeters. It's just measuring the distance that goes around there. So if this is 2 centimeters, the entire distance is just still measured in centimeters. So it's 14 centimeters on that one. All right, on the next one, I'm looking for the perimeter of that square. Again, I could just add up all of these sides. I have the equation on the formula sheet saying 4s, so 4 times s, which is any one of these sides. If it's a square, I know that all 4 are the same, which is why I'm allowed to really just do that. 4 times that is just a faster way to add up those 4 sides. So here, the perimeter would be 20 centimeters. All right, on this one, we have to actually find a missing side. So we're looking for the perimeter of that triangle, so we're going to try to add up these 3 sides. We don't actually have this one yet, so I need to use Pythagorean theorem to find that. Remember, this is used when I have 2 sides, and I'm trying to find that missing side. I have this side given to me. That has to be C. It's across from the right angle. It's got to be the longest side, and it has to be C in this equation. So I'm going to plug that in there, and this one, since this is already labeled as B, I'm going to label that as A. So 15 squared plus b squared, which I don't know yet, equals 17 squared. So we're going to square each of those numbers first. Oh, I'm sorry, I wrote that wrong. Sorry, that's 225. Squaring 15 to get 225, squaring 17 to get 289, and then we're going to subtract 225 on both sides. So that gives me that b squared is 64. So I have one more step there. I want to take the square root of that and the square root of that. That gets me just b by itself, and that would give me 8. So this length is 8. Not quite done yet. I want to find the perimeter, so I'm going to add up these 3 sides. 15 plus 17 plus 8. You notice that there's no perimeter of a triangle on the formula sheet, because really, it's just adding up those 3 sides. Perimeter is always just adding up the sides that we have. So that would be 32 plus 8 is 40. We don't have units here, so I'm just going to label that just as 40. All right, we want to find the perimeter of a circle, which is just a different way to say the circumference. So the circumference of a circle is just the distance around. Again, I have these 2 formulas, 2 pi r, so just multiplying each of those, or pi times the diameter. Seeing that I'm given the entire length there, that's the diameter going all the way across the circle through the middle. I would just use this one. You could have cut it in half and then use that, but it's the exact same thing. I would just use this and do pi times the diameter that I'm given there, which is 18. I'm going to round pi to 3.14, and that would give me my final circumference of 56.52. This is measured in inches, so the distance around is still going to be measured in inches there. All right, area is the number of square units. It's literally the number of little squares that I could fit inside of a shape. So perimeter is going around the outside. Area is the amount of space on the inside. It's actually a literal number of units that I could squeeze inside of here. It's how many of those square units would actually fit in there to cover the entire shape. So I'm looking for how many square units it would take to cover this. There's a visualization that you could use. Actually, what this is saying is that this is split into, it's not exactly even, but 5 equal parts. and this side is split into 2 equal parts. It's literally that measurement. It's just saying that there are 10 squares that I can fit in there. Easier way to find that, just using the formula of a rectangle, is length times the width. So length times width, which is 5 times 2. So the area is 10, and we're going to use centimeters squared for that, because it literally represents the number of square centimeters. This is a 1 by 1 square that fits into this. It's 10 of those that could fit in there. So we use the units of centimeters squared. All right, the area of that triangle. So I have extra numbers in here. I'm going to write down the formula first just so I can think about what I actually need. Area of a triangle is 1/2 base times height. The height is always going straight up and down from the bottom to the top. That is this 4. It's connected to a right angle. So this 5 kind of looks like it might be the height, but that's slanted. I don't want to use that. The height here is 4, and the base is always on the bottom, also connected to that right angle. So 12 is my base, 4 is my height. That would be 1/2 times 12 times 4, which is 24. Again, I don't have any units here. Here, I'm just going to say units squared. I don't really know what the units are, but I know that they're going to be squared. All right, now I want to find the area of a trapezoid. So again, I'm going to write out that formula. Area of a trapezoid. It's 1/2 times the height times B1 plus B2. So this B1 and B2, it's just a way to label the base 1 and base 2. It's not an exponent or anything. It's just saying the top and the bottom. It actually doesn't matter which one's base 1 and base 2. We could flip this shape and it would have the same area. I'm going to say that this is my base 1, and this is my base 2, since I think that's the way it's shown on the formula sheet. So we're going to use 6 as base 1 and 8 as base 2. Again, we're not squaring this. We're just leaving that as a normal 8. And then writing 1/2 times the height. It's always going straight up and down. It's not the slanted sides here. It's going straight up and down, and it's connected at that right angle, so here it's 4. So 1/2 times 4. Actually, I'm going to do it in the parentheses first. So I'm going to follow order of operations. I'm going to do in the parentheses first to get 14. So my area equals 1/2 times 4 times that changes to 14. And now I can just multiply, I can just multiply all 3 of those numbers together and get that my area is 28 again. I don't really know what the units are, but I know that they're going to be squared. All right, now we want to try to find the area of this semicircle. So I can find the area of a normal circle, which is pi r squared. If it's a semicircle, really I'm just going to take that number. It's just directly half of a, that was okay up until that point. It was really just directly half of a circle. So if I could find the area of this entire circle, I could divide that by 2, and that would find the area of just this part of it, just the semicircle that I'm showing here. So I have to think about how to find the area of that full circle. That requires the radius. Here I'm given the entire distance across. That's going from one end to the other through the middle of that circle. That's the diameter. So the radius is half of that. I'm going to cut that in half and get a radius of 6. That's what I'm going to plug in here. The area equals pi times the radius squared, or pi times 36, or 113.04. That's the area of a full circle. What I found here is if this was an entire circle. I have to divide this by 2 because this is only a semicircle. I'm going to take that, divide it by 2, and get that the area of this shape is 56.52. And again, my units are talking about how many square units literally fit into that shape. So that is centimeters squared.